Now let's go on to the similar figures direct scale level 1. Here's an example where it says triangle PQR is dilated by a scale factor of 2/3 to form triangle P prime, Q prime, R prime. Side PQ measures 48 degrees. What is the measure of side P prime, Q prime? So all we would have to do is multiply 48 times 2/3. 48 times 2/3 would give you 32. So the measure of side P prime, Q prime is 32. That is what all the questions in this one are like. Well, maybe not. Let's see. Show the question. Let's do a new problem. Oh, some of them look a little different. So triangle UVW is dilated by a scale factor of 2/3 to form the primes of it. What is the measure of side WU? All right. So we need to look at, this is the image. So we want the pre-image. So we're going backwards. Okay, so they really are trying to trick you on this one. We know that W prime U prime is 36. So what would WU have to be from the beginning with a scale factor of 2/3 to get to 36? So you'd have to think about it, and they've got an image here where they drew it in. We know it had to be bigger, but you can set it up like this: WU times 2/3 equals W prime U prime. And we know that W prime U prime is 36, so we plug that into the W prime U prime spot. And then just divide both sides by 2/3, which is the same thing as multiplying by 3/2. And you get that the original WU, the preimage, is 54. Let's look at a new one. Like this one. We're given the preimage, JKL. It's dilated by a scale factor of 3/4 to go to the J prime, K prime, L prime. What is the measure of side L prime, J prime? So this is 48 right here. It's the one I need, LJ. I'd multiply that by 3/4, and that would give me L prime, J prime. When they give me the pre-image links, it's a lot easier because I just multiply by the scale factor. But like in the last example, if they give you the image links, you have to multiply by the reciprocal of it or divide by it. Okay, so let's see. 48 times 3/4 gives me 36. So here's another one where they gave us the primes. They gave us the image. And they want us to get back to the pre-image length of US. So I know US would be over here. And I don't know what its length is, but I know that the image is 20. And I know there was a dilation by a scale factor of 2/3. So I would just do 20 divided by 2/3 to get back to the original, which is 20 times 3/2. And here is the setup algebraically. 20 times 3/2, you're going to get that the original US is 30. All right, now the last section is the level 2 of these. And it's where that gives you both, and it wants you to find the missing side length. So you're just going to set up a proportion. It doesn't tell you, it tells you they're similar, but it doesn't tell you the scale factor. We've done this, guys. If we know they're similar, we know how to set this up. It wants the measure of IJ. So in this spot is our unknown. You can put an X in that spot. And you have several ways you can set this up. You could say 5:4 as X is to 13.2. You could say 5 is to X as 4 is to 13.2. And you just cross multiply and solve. Now what they're doing is they're looking for a scale factor between the two sides, and they find it, and then they multiply. We can just set up a proportion. Okay, so I think that we're more accustomed to setting up a proportion, so that's what I did here. 5:4 as X, the side that we need, is to 13.2. We cross multiply. We get 66 equals 4X. We divide by 4, and we get X is 16/5. Now, they do the same thing. It just looks different. They find the scale factor, and then they multiply by that, and they get the same answer we got. I recommend you set up a proportion to solve these. Okay, so what will we do here? We would set up a proportion. They want IJ. So 8 is to 3.2 as 32 is to X, and you would end up with a 12.8.